So I'm going to get started. So thanks everyone that's called in. Welcome to the start of the workshop on constraint solving and quantum computing, QCP 2021, as part of the annual conference on constraint programming. I'm really glad that you could join us today. Just a quick reminder, as I just stated, I've put the link for the Slack workspace in the group chat here, and I would encourage you to join that if you can, because I think Slack is a really nice way to have a fluid, ongoing discussion throughout the day. So my name is Kyle Booth, and I'm a scientist with the Quantum AI Lab at the NASA Ames Research Center. And I have spent time organizing this event alongside my colleagues, Eleanor Riafel, who is also, she's the leader of the Quantum AI Lab at NASA, as well as Brian O'Gorman, who is with IBM. And so the intent of this particular workshop is to try and introduce classical constraint solving researchers to key concepts and research ideas in quantum computing. I personally believe that one thing that's really nice about the modular design of constraint programming as a paradigm is that it makes a great candidate for hybridization with various quantum methods, not to mention, its potential for use in solving various ongoing design problems in quantum computers. And there'll be more on that in the second session of today. And so the structure for the workshop, so essentially what's going to happen is we're going to have a mixture of invited talks as well as talks that are given based on accepted abstracts. So if you go on the QCP site or the Slack workspace, you can basically see a link for the abstract booklet where you can scroll through all the abstracts that were accepted to the workshop. One thing I'll note is that a lot of the talks are pre-recorded, but some are given live. However, given the nature of the pre-recorded talks, authors will be present to answer questions after the talks. So please, feel free to ask questions, kind of get clarifications on anything that kind of strikes you as you watch the presentations, but hold them until after the talk is complete. We will have a morning break and an afternoon break of 10 minutes each according to the schedule, as well as a 30-minute lunch break, during which, depending on how the day unfolds, we'll host a casual discussion panel. In the Slack workspace, there's actually a channel entitled Lunch Discussion, where I would appreciate if you could post questions, curiosities about quantum computing that are perhaps not related to any of the talks in the workshop. And so lastly, I want to emphasize, feel free to ask questions, share relevant resources throughout the day on the Slack workspace. Again, please take a moment to join that if you haven't already. And let's have a fantastic day. So our first session today is going to essentially provide an overview to introductory concepts in quantum computing, and also give key insight into how you can solve constraint problems on real quantum computers today. So in our first talk, Ryan LaRose will lead with his talk entitled Quantum Computing for Computer Scientists. Ryan is a PhD student at Michigan State University in the Department of Computational Mathematics, Science, and Engineering. He's completed a variety of interesting internships in quantum computing at Google X, NASA, and IBM. And Ryan's been involved in numerous summer schools and boot camps in quantum computing, including those recently held at UC Berkeley, Duke University, and the University of Tokyo.